Good evening, everyone. My name is Atul Mangal. I am a third year chemical engineering student at IIT Delhi. I am working as a research intern with Shloka at Maritime Research Center. Today, I am going to present my ongoing project titled Modeling and Simulation Framework from Brahmaputra Basin. First, let me brief you about the outlines. I will start with an introduction to the Brahmaputra River Basin and its importance. Next, I will discuss the opportunities and challenges within the basin. After that, I will focus on climate change impacts on inland fisheries of the region. Then I will explain our research objectives and modeling approach. Then I will briefly discuss the challenges we faced and our proposed future work. Let's begin with the introduction. The Brahmaputra is a transboundary river, flows through Tibet, India, and Bangladesh, with its basin extending to Bhutan. It supports nearly 130 million people across its coast. The basin is rich in biodiversity and home to more than 216 inland fish species. It covers about 5.9% of India's geographical area and plays a vital role in agriculture, food production, and inland fisheries. In 2023-24 alone, it contributed more than 5.5 lakh metric tons of inland fish. It is also important inland waterway. In 24-25, around 9 lakh tons were transported through national waterway too. Now, let us look at the key opportunities present in the basin. First, the hydropower potential. The basin has the highest hydropower potential in India, about 66,000 megawatts. Big projects like Upper Siang and Dibang dams are planned, and the government has approved the funds to add around 31,000 megawatt of capacity by 2032. Second, fisheries and aquaculture. There are plans to boost fish production with modern hatcheries and better cold storage. This will create local jobs and cut fish imports. About 2,100 crores, about 2,100 crore have been approved for fisheries project in the northeast. Third, inland waterways. Efforts are on to develop river tourism and ecology friendly cruises on national waterway too. Over 1,100 crores has been set aside for new terminals, ship repair, and ferry services to improve transport and livelihoods. Together, these opportunities can help grow the region's economy. However, the basin is facing multiple interconnected challenges. Environmentally, the region is prone to frequent flooding, severe riverbank erosion, sedimentation, and increasing pollution. These issues are being intensified by climate change, which is making extreme weather events more common and unpredictable. Socioeconomically, the area struggles with poor infrastructure, high population pressure, poverty, and unsustainable fishing practices, all of which add stress to the ecosystem and the people depending on it. Geopolitically, the situation is complicated by transboundary disputes, the construction of upstream dams, and the limited regional cooperation, especially between neighboring countries. Among all the challenges, climate change stands as one of the most urgent threats. The region is highly climate sensitive, and we are already seeing the effects. Rising temperatures, erratic rainfall patterns, and frequent flooding are damaging fish ponds, breeding habitats, and landing sites. Along with these, warmer temperatures are disturbing fish breeding cycles. If you look at the bar graph here, it shows the GSI for the Hilsa fish. You can see that the GSI is highest from October to February, which means that the reproduction is higher when the temperatures are lower. This shows a negative correlation between the temperature and the breeding activity. Another major impact is the shifting of the species composition. The total inland fish catch in Guwahati region increased from about 56,000 kg in 1975 to over 1 lakh kg in 2010. But if you look at the two graphs below, you can see an important change. The left graph shows the total catch in kilograms for each fish group. The right graph shows the same data as a percentage share. Notice how the bars for major calves and Hilsa are higher in 1975 but drops in 2010. At the same time, the bars for the minor calves are much bigger in 2010 compared to 1975. This means high value fish stocks are declining while low value species are increasing. This shift impacts both ecological balance and the incomes of local fishing communities. So, what is our research objective for this project? Our primary goal is to develop a modeling and simulation framework that can help us understand the Brahmaputra ecosystem. We aim to model key parameters like climate variability, hydrological factors, and ecological aspects. Then we will integrate this into a broader policy framework for sustainable development. For now, the current focus is on modeling the impact of climate change on inland fisheries. Now, one question arises, why does this modeling framework actually work? Look at the two graphs. On the left, you can see that temperature has increased over the years, fish production has dropped. On the right, you will see a similar trend. Lower rainfall is linked to falling fish catch. These graphs use data from Bangladesh, which shares the Brahmaputra ecosystem, so the trends downstream help us validate climate risks in Assam and Northeast India. It is same river system after all. That's why using this kind of regional data makes our model more accurate and relevant. Now, let me explain the modeling approach. We use a range of data sets, including historical reports of temperature, rainfall, and fish production. This includes time series, state-wise, and species-specific inland fish data to capture long-term climate fishery linkage. Now, let's talk about the methodology. We are building a black box model that uses historical data on fish production, temperature, and rainfall as input. It maps climate variables to fish production without needing detailed biological or ecological information. The model helps us identify key relations and generate predictive insights to support better governance of inland fisheries. Ultimately, the goal is to quantify how climate is impacting the fishery sector in the region. So let's talk about the climate changes we are currently facing. First, the challenges we are facing. First, data ability is a major issue. As you can see in the left and right tables, we have mostly state-wise fish production data and species-specific records are limited to specific years. This makes it tough to track long-term trends. Now, look at the bottom table. The rainfall is grouped for Assam and Meghalaya division, so we cannot isolate the changes at the smaller scale. Other challenges include difficulties in quantifying extreme climatic events and isolating climatic impacts from factors like overfishing. To overcome these challenges, we have mapped out our future tasks. First, we will build a dataset for historical time series, temperature, rainfall, and fish stock for multiple fish harbors in Assam. Next, we will train our model on these datasets and interpret the results to identify key trends and correlations. Then, we will validate the model by collecting ground data through site visits and fieldwork. We can expand the model by incorporating hydrological data for water flood sensitivity. We can refine it by including other relevant parameters that affect fish stocks. Lastly, we hope to engage with policymakers to apply this research in a real world for sustainable management and planning. We hope the insights from this modeling effort will help to contribute better planning, conservation, and sustainable development in the region. That's all from my side. Thank you so much for your attention. If you have any questions, please let me know.